Hi, I am Pranay Dayal from Group 3 in KDD project. Our assigned topic is frequent pattern growth strategy. This algorithm is about extracting frequent item sets from a given set of transactions. And this algorithm mainly involves two steps. The first one being constructing a FP tree, followed by mining the constructed tree for frequent items. These identified frequent item sets acts as an important knowledge in introducing many marketing strategies. So I feel there is a necessity to adopt this algorithm such that it is suitable for large scale transactions. So my presentation is basically about necessity and different techniques involved in scaling this algorithm. We know data is huge and day by day the producing data is been increasing and it is really hard to store data and maintain and process it. But FP growth is essentially a main memory based frequent pattern mining method. We know as the data is keep increasing day by day, what happens if our data is base is large or when the minimum support threshold is quite low? It is quite unrealistic to assume that the FPT of a database can fit in the main memory. What's the solution for this? A disk-based method should be worked out to ensure that mining is highly scalable. So we need a method which is developed to first partition the database into a set of projected databases and then for each projected database construct and mine its corresponding FP tree individually. A projected database for X is derived from database by collecting all the transactions containing X and removing from them infrequent items and all frequent items after X in the list of frequent items, and finally after removing X itself. And we have two different methods for database projection. The first one is parallel projection and the second one being partition projection. In parallel projection, we scan the database to be projected once where the database could be either a transaction database or a projected database. Since a transaction is projected in parallel to all the projected databases in one scan, it is called as parallel projection. Parallel projection facilitates parallel processing because all the projected databases are available for mining at the end of the scan, and these projected databases can be mined in parallel. However, since each transaction in the database is projected to multiple projected databases, if a database contains many long transactions with multiple frequent items, the total size of the projected database could be multiple times of the original one. So this will be an overhead. So we need a different technique, and which is a partition projection method. In partition projection, when scanning the database to be projected, a transaction T is projected to the projected database only if it is a frequent item and there is no other item after it in the list of frequent items. Since a transaction is projected to only one projected database at the database scan, after the scan, the database is partitioned by projections into a set of projected database and hence is called partition projection. And now let us compare the functionalities of parallel projection and partition projection. In parallel projection, we project the database in parallel for each frequent item. Whereas in partition projection, we partition the database based on the ordered frequent items. We know parallel projection is space costly because it requires a lot of generates a lot of FP trees. But on partition projection on the other times takes more execution time because in parallel projection we have parallel processing, it executes a little faster. Summary: when support is very low, FP tree becomes bushy, and in such cases the degree of sharing in branches of FP tree becomes low. The overhead of links makes the size of FP tree large. Therefore, instead of building FP tree, we should construct projected databases. Therefore, even for very large or sparse database, after one or few rounds of database projection, FP tree can be used for all the remaining mining tasks. Thank you.